Today you will understand how the structure of a house is made, and for that we are going to build a mini house. But hold on, it's not just any mini house. We are going to build a mini cement house. A mini masonry house. How does a house stand up? How does it withstand all that weight that's on top of the walls? There's a lot of science, there's a lot of engineering behind it. And we wanted to show this to you, so we thought that maybe it would be a good idea to build a house. Initially, I wanted to construct a Hollywood-style mansion, but I realized it would be time-consuming. Spend a bit of money and we're not in Hollywood after all, but that's not a problem, no. We're building here a mini house, a tiny little house, but that follows all the steps with the same materials, the same procedures, a real house. Like the house you live in, like the houses we see built around. Some people sent us a video a while ago where some people built tiny houses using real-world construction techniques. And here at Manual do Mundo, everyone was crazy to do that because it's very tempting to be able to make a beam, a pillar, a slab, using rebar, cement, and everything else, but this tiny. But we waited for the right time, and the right time is now with the support of Amigo Construtor. They are a platform, a website made to help people with this construction theme. This applies to professionals, resellers, and the general public alike. And that's why in today's work we're going to use Cowie Cement, which is one of Amigo's cements. Building a house is no joke. It involves a lot of safety issues, technical processes, standards, and even here in this little house, we had the technical help of an engineer who is Paulo, Fernando's father, the physicist who works with us, and Roberto, Pena's father, who is an architect. You've already seen him here as he helped build the submarine. And we can get this technical support within the platform, builder friend. Just look. Look how cool. Right off the bat, there's a section of tips and solutions. There are dozens and dozens of tips for the work for your house. There are trainings that you can do here, from finances in the work to how to make a concrete bench, care, storage of material. There is also a section to ask questions where you can not only ask your questions, but also see the questions that were asked by other people. To begin discussing our small home, let's sketch it out. Visualize what we desire from this house. What we thought is the simplest possible house, with 2 bedrooms, living room, kitchen, bathroom, a service area, plus a 2-story house, because then the construction becomes a little more challenging. We have to have a more robust structure. Due to the complexity of this project, Pena and Luisa will assist me. The hands you will see working now are theirs. Let's start with our land. We don't want to build the house on the backyard ground. So we made a wooden form, put soil on top, and we need to make this soil extremely flat. Here we are doing it with a shovel, but in real life, this will be done with a grader, with a loader shovel and everything else. The ground can't be soft, fluffy, so it needs compaction. Once again, we're doing it by hand. You know that in real life, there are specific machines that will really pound this earth because the house can't be built on a soft place. To take the house off the paper from the blueprint and bring it to real life, it needs to be drawn on the ground. This in construction is done with lines. We're going to do it here with lines as well. At this stage, you have to be very careful. The 90-degree angles have to be perfect because if you make a mistake here, the house will be crooked for the rest of its life. It's time to start putting this house up, right? The first thing that needs to be built is the foundation. It's what goes under the house to ensure the structure. At Amigo Construtor, you'll find many articles on foundations, including types and how to build them. Here we chose to make isolated footings on strip foundations. What are the footings? They work more or less as if it were a foot, a shoe of the pillars. The pillars are those vertical structures, right? If it were a human body, we could compare it to a vertebra, for example. At the same time, we need structures that are horizontal where the walls go on top, and there we will build some beams. So, whenever we have structures in the horizontal, we call them beams. Whenever we have structures in the vertical, we call them pillars. In this case, these beams that are under the ground, we call them foundation beams. The first thing we're going to do is remove the soil, open the holes where we're going to place the footings and the foundation beam. Then we put the crushed stone, the steel frames, then we'll talk a little more about them, and then the concrete. And here you can see that since our soil wasn't very well compacted, our foundation beam ended up crooked. The technique we tried to use is called foundation beam against a slope, which is you make a precise hole in the ground, then you put the frame and the concrete. This is used a lot, only usually the soil is well compacted so you can make a perfect hole. In our case, we did try to compact this soil as much as possible. We even added water, but since our scale is very different from the real world, it's much smaller. The soil ended up being kind of soft. It worked out. The construction would be safe with this, but it looked ugly. We want it to look nicer. So we're gonna change the technique. This time we're gonna put forms on the side, and then we'll have a well-defined beam that the concrete can't escape from. You can see that it looks much nicer now, right? It's time to make the floor slab. It's a structure that goes under the floor of your house, and it's what will ensure that the floor doesn't crack in the middle. First, you have to remove the soil because this will be done at a level slightly below the foundation. Then we spread gravel, put a tarp, steel frame, and finally the concrete. You may have found this tarp over the gravel strange, but this is the waterproofing. This is crucial in a house to prevent water from rising through the concrete. In real life, it's possible that the entire foundation is waterproofed. We're not going to do that in our mini house because it was more to show you that this exists. We're going to make the pillars and beams of the house now, but since this is a very important and also very cool stage, we have a lot to learn. I wanted to make details for you to be able to follow. So the first thing I'm going to build is a mold, like a cake mold, where we're going to put the concrete with reinforcement inside. For this, I already need to know the size of the pillar and the beam. In real life, this would be done with pieces of pine wood or plywood. Usually it's a plywood that has a treatment inside, so you can peel it off the concrete later, and it looks nice. We will use foam paper for this, but in real construction, glue wouldn't be used. People would be using screws and nails and a bit of wire here to assemble the form. And then they would have the advantage that wood with wood, the moment you put one next to the other, you can tighten it very well with the screw and it doesn't leak cement. I must seal everything with hot glue to prevent leaks. Next, let's construct the steel frame. This here in a house is extremely important because the steel will work together with the concrete. Concrete is very good if you press it, okay? If you put force on it, it won't give in, not even if hell freezes over. A material extremely resistant to this. But when we talk about traction, if we have, for example, a piece like this, right? A beam, who is going to work in this case, will be the steel. Who will be supporting most of the force is the steel. And that's why we will have both things in the pillars and beams. The name of this is reinforced concrete. We have developed some techniques here to bend this wire mesh, but of course in real life it would be a much more robust material. Lengthwise we would have the rebars, and perpendicular to it we would have the stirrups, which are these irons that form these squares. Before placing the frame in the mold, I need to put some spacers, because the frame needs to be exactly in the center of the beam or pillar. Let's concrete. Since we are making a much smaller house, some things won't work exactly like in real life. The concrete mix recipe specifies the proportions of cement, sand, and gravel used. We're not following the real life recipe as it wouldn't fit our mold. I'm using a mix of fine and coarse sand instead of gravel. Even without using the perfect concrete recipe, we'll have a super sturdy house, as that's a key characteristic of cement. Cement, when combined with iron, forms an extremely durable structure that is easy to work with. The consistency of concrete always surprises me. Oh, you turn it, it doesn't fall. Let's do this in life. I mean, not in real life, right? In the real little house, the little wire tips left out are not due to negligence. It's called a start. It's where we attach the steel structure of the pillars. In our little house, there are 8 pillars. The shapes are made the way you've already seen, but on top. They have to connect with the shapes of the beams. In addition, the frames of the beams also have to be tied with the frames of the pillars. Often this is done with wire, but here, as a tiny wire would be very bad to handle, we are welding, which is also a possible technique in construction. At this stage, we also take the opportunity to put the form of the slab, this wood that goes underneath. On top of it goes the grid screen that will also hold the slab, which has to be tied to everything you've already seen. The traditional would be to first concrete the pillar, then the beam, and the slab. In our little house, to make it more practical, we're going to concrete everything all at once. It's a delicate stage because we can't leave too many bubbles in there. If there are bubbles, in the end, it will be a hole in the construction, and that's very bad. One of the ways to avoid these bubbles is to vibrate a little the sides of the beams and pillars, so the air goes up. While the concrete was being poured, we noticed that there were some leaks, and at that time you have to act very quickly. So we worked very hard to think of a way to plug this leak. One of the solutions was to put some rubber bands around the molds and also brace using cardboard tubes. You thought it was easy. There's still the second floor. You already know the way now. We left some starters to fit the frame of the pillar that goes on top. Since we already have some experience with the lower floor, we decided to put more effort here. To ensure that the shapes were exactly vertical, we used a miniature plumb line. Just look at this little beauty. Another innovation on the second floor is to use these triangular structures, they call them ties, to prevent the beam shapes from opening. We've arrived at one of the coolest parts, which is to deform, which is to remove all this shell and see the concrete underneath. After all, is what we built good, or is it all full of holes? I think we're gonna need a little bit of plaster here, right? But overall, it's looking good. Look, smooth, smooth. We're gonna close the walls with these mini blocks made of concrete. If it were in real life, it would be a block like this one, see? We would also like to make the miniature with holes. We even made a positive here on the 3D printer to make a mold to then fill with silicone, and the silicone would be the shape of the concrete, but at this size it wouldn't work out very well. So in the end, we made a medium density fiberboard mold cut on the laser, and it's about 1,500 that we need. We made a little more to ensure. Let's then start the stairs. We are going to fit her steps into this pillar frame that is here in the middle. Since we are building a miniature here, we had to glue one step to another to work. But if it were a real construction, the very weight of the stairs would make it firm. To finish, we cut the leftover rebar here on top and concrete this middle pillar. And after many days of work, our little house is ready. I mean, it's not exactly ready because it lacks a roof, paint, plaster, those things, but its structure, the masonry, the part that supports the house, the entire skeleton of the house, is 100% finished. This house would never fall because all the beams, pillars, and everything that supports the house has already been built. Here on the first floor, we have a living room. It's one of the larger rooms in the house, and in it is the spiral staircase that goes up to the second floor. It was made of precast concrete. This is a simulation, a concrete painted piece to make a staircase. In real life, precast concrete pieces are commonly used, especially in barbecues. At the back of the house, there's a laundry area that is exposed. It gives access to the kitchen, and from here, we can see the small window of the bathroom. Here, there is a very interesting thing on the exit door, which is this structure above. It is called a lintel. It's a small beam that serves to support the wall that is above the door. Here we made it out of wood. There is wood in real life, but ideally it should also be made of concrete. In fact, you can buy precast concrete lintels. Going up the spiral staircase on the second floor, we will have a very large room. In the original design of the house, here we would have 2 bedrooms and a bathroom, but I must confess that these walls were much more work than we were imagining to make in miniature. Fit everything, so we made a very technical decision to turn everything into a single room in this loft concept more modern. But seriously, in a real house, this would be possible because the structure of this house here is based on beams and pillars. This means the walls do not have a structural function and are not supporting the house. So we can either not build or remove a wall, open a door where there is a window, change the door's location. This is not a problem at all. The beams and pillars support everything. Interestingly, the second floor windows lack lintels. What supports the top part of the window is the beam itself. It might seem strange to have windows like this, but it's common. Look at the window behind me. Let's agree, shall we? A cool house, like this one here, you haven't seen anywhere on YouTube. I think it's worth that well done thumbs up down there, huh? And don't forget to leave in the comments too, what is the method you think is cool for us to use to test the structure of this house? Because seriously, it was made exactly like a real house is made, and this structure is really sturdy. It should hold a lot of weight up here. Whether you're building your own house or you're a professional in construction, an engineer, architect, master builder, bricklayer, or building materials dealer, be sure to visit the Amigo Construtor website and benefit from the resources available there. There's really a lot there. After watching this video, you probably felt like building things out of cement. So one of the best tips I can give you is to watch our video where we taught how to make concrete weights. The weight is very accurate and it's easy to make.